0.84, that's a z-score, everyone. Be careful, z-scores sometimes look like probabilities. That's a z-score. The z-score was 0.8. Now, you know what one student once told me when they saw this? They go, I'll just type 0.2. They know that the answer would give the answer over here, and they know the answer will be negative, so I'll put a negative symbol, but they'll steal the number here. They just won't put the negative symbol down. Will that work because of symmetry? Absolutely. So if you like that too. So if I put inverse norm 0.2, the calculator is going to go negative 0.84, and you can just take off the negative and know that this z-score has to be what? Positive. Does that make sense? So some students do that. They go, I'll just put the number, but I know negatives and positives. Cool? And one more, and then we'll have some fun, do some application problems. One more with this, because I haven't presented this yet. And when this is for the inverse norm button after chapter 8. Ready? What if I shaded 90% in the middle? And I want both those z-scores. You've got to help me figure out a way how to do this with this button. So what I'm doing now, when I'm shading 90% of the bell curve, the normal distribution. 90% of the normal curve. Okay. So I shade it in the middle. And I want to know this z-score, which will be negative, everyone agree? And I want that z-score, which will be positive.
It's a 5, that should be 5, right?
So, oh, you're on to this. I want to use this button. It's the only button available on the calculator, but I have to put the percentage from the left side. So Art, very good, he's focused right in there. How could you and I mathematically figure out the percentage right there? Everything has to add up to what? 100%. So Art took 100% and did this mentally, I know. You subtracted 90% in your head, which gave you 10%. So when he knew that these two areas right here have to add up to 10%, right? But there's two of them, so he divided it by 2. And what's 10% divided by 2? 5%. So what's the shaded area right here? 5% shaded, and I'll just put in inverse norm 5%. How do you write 5% though? Is it 0.5 or 0.05?
0.05.
0.05. So let me get that out of the way. That's 5%. So I'm going to type that. Right? And I'm going to hit the lights, and let's see what the two z-scores are. You can do it too. Inverse norm 0.05. This time, everyone, I'm going to do it like, whoops. This time I'll do it like the default. Watch. Let's go. Number 3, 0.05, and I'm just going to hit enter. Because I know the default is I'll have to put that 0 and 1. What's the z-score on the left side?
Negative 1.64.
And I'll go out about 3 places, 3 decimal places. Negative 1.645, and the right?
Same.
The same. Because of the symmetry. It's all symmetrical. Ta-da! You are an expert with this calculus, with the normal distribution. So very good. That's it. That means you can do anything with this in terms of finding z-scores. Think about it. What did I have to do back in the day? I hated it, everyone. Every stat problem, and you stuck your card back there and do that. Now, are there classes still taught like that today? Absolutely. I'm not making fun of them, but if they're doing it, that means they're not using a calculator, but they're probably using really neat numbers, so the z-score comes out to a really neat number. You can still do it. Some teachers still teach that way, but golly, use the technology, right? All it's doing is computing the area under this curve like we've been doing. Uses calculus. All right. So I'm going to rate this. Now let's have fun. Real life stuff. Let's get to an application problem. All right. So when I was looking at this earlier today, and I'm like, what would be fun for this class? Anybody in this class going into nursing? See, I knew it. And when I had a feeling there's a lot of hands going up. So I'm going to use a problem. There was one about M&Ms. Not M&Ms, Chips Ahoy. I'm going to leave that for you to practice at home. Cool. What they did, I teach at Naval Academy. Well, at the United States Air Force Academy, the cadets got together, got a lot of Chips Ahoy bags, the 18-ounce bag. Do you really think it has the exact number of chocolate chips in every bag? No, but they figured out after looking at all the distribution, it was bell-shaped, you know? A lot of bags had chips around here, but there were some bags that had a lot of chips. I should go to this end. A lot of chips, and then there were some bags where you got gypped, and the cookies didn't have many what? Chocolate chips, and it was bell-shaped, okay? So that I'll leave for practice for you. I'm going to do number 41, it's gestation period. So this is on page 378. And in these problems are when they have to tell you two very important numbers. They have to give you the mean, whatever it is, if it's normal, bell shape. They have to, oh, and here's something else. They have to tell you it's normally distributed. Some of them got to tell you that because unless we're aware of this, true? So they have to state that. They'll give you the mean, they'll give you a standard deviation somewhere too. So those two numbers are the important numbers. All right, here we go. The length of human pregnancies are approximately normally distributed. Check, we know it's normally distributed. The mean is 266 days. All right. I want to agree with gestation period. I always heard, what, 9 months? 9 months, yeah. The standard deviation is 16 days. And then they ask a bunch of questions. They're going to ask probability questions. But these have to be given. This is what I encourage everyone to do. The minute you get this, I would go off to the side of your paper. It doesn't have to be that big. And just draw an image of what's going on here. Because they did say this was normally distributed, right? And I would just go off somewhere and just go, okay, this was approximately normally distributed population. That's what you have. So you know it's a bell-shaped curve, representing what's going on with these pregnancies. And I would just go off to the side. It doesn't have to be that big. Look how small mine is, right? And I'm just going to leave it up here. Oh, you know what I could do? I can make it big because I want to make sure all you in the back can see this. I'll use this one. And everyone go in here and let's just write a few numbers down. Okay? I'll get this out of the way. Who already knows what's right here?
Zero or
Oh good,
266.
z equals 0. I'll write that. But what's the x value here?
266.
So 266, right? I'll call it here. You're x. You're my x value. My x, this one, x, 266. What's x right here? Do you remember how to do this?
Plus 16.
Yeah, the 16, which is
282.
282. That would be 282 days until the baby was born, right? Gestation period. How do I get this?
Plus 16 more.
298.
8.
All right. That's, if you want to do a third tick mark, you can. I just get the image going. I'll just go 2 tick marks out. What's 2 tick marks this way? We'll just see.
250.
250 and
234.
234.
cool. And hey, right underneath it, let's list z-scores. What's the z-scores? Z-score here? 0. Z-score here? 1. Z-score here? 2. Z-score here? And we'll use this as a guide. Every time we do a problem, we can check it, kind of look at the image and go, am I doing this right? Why am I getting 99%? That doesn't seem right. There's a 99% chance a baby could be 200, gestation period, 298 days or more? That doesn't seem right. So we do that. All right. Letter A. The question is, and I'll write this on the board, what proportion of pregnancies last more than 270 days? What proportion of pregnancies last more than 270 days? All right, question mark. If I want a chance to write that down. What proportion of pregnancies last more than 270 days? Hey, sometimes they word this question a little differently, so I want to present it that way. That way nothing tricks you on tests, right? I mean, it's like sometimes the wording's a little different, and we're like, This is gonna mean the same thing. What if I said this? And when I went over to Anne Arundel Medical Center and I randomly picked one woman, okay, who's pregnant. Just randomly pick one woman who's pregnant from a list. What's the probability that that randomly chosen woman's gestation period lasts more than 270 days? That's the same question. Okay? So I'll repeat that, just so you know. It's like, I'm saying I randomly pick one woman who's already pregnant, right? And I go, what's the probability that that randomly chosen woman, I randomly chose her, that her gestation period is 270 days or longer, right? Same type of question. So now, to answer this, we're going to do it in 3 steps. It's the 3-step method. Step 1, make a picture. And this picture is important. I want you to draw something. The bell. Draw a bell. So number 1, make a picture. Now I have a feeling after a while, because a lot of you do this, you'll make a mental image. You'll make this image mentally, and I won't even see. I go, gosh, Caitlin did this problem right, but I didn't see her drawing on the paper. That's okay. You probably thought of this mentally. What's in the middle?
266.
266 days. Where's 270? Off to the right somewhere? Yeah, so we just go off to the right a little bit. It doesn't have to be perfect. We're just like, well, 270 is over here. By the wording in this question, which way should I shade?
To the right.
To the right. Everyone agree? So that's what we're going to do. We're going to shade. And if you don't mind, I want you to do this over and over. Every problem, make a picture, shade. Which way am I shading? Right? By the wording. What they said less than. Okay, I'll shade that way. That's step 1. We're good there. Now step 2, you need to find the z-score associated with x equal to 270. I need you to find that z-score that is associated with the 270 days for this problem. And you go, we haven't talked about that all day. Well, there's a formula for it. And it's on the formula sheet. You've actually used it before, and I'm going to write it on the board now. Do you know, Art?
4 over 16 1/4, right?
That's right. That's exactly it. So I'm going to put this on the board right now. Art, outstanding. There's a z-score formula. Do you remember this? Z-score equals x minus mu over standard deviation. I can find any z-score with that formula right there. I'll enter the x value, I'll subtract the mean, the mu, divide the standard deviation. And I'll get that number Art just read to us. Every time. So you can use this always in this step right here. So what's the z-score equal to? X minus mu over sigma. X minus mean over standard deviation. So I get, what's the x value? 270. What was the mean?
266.
266. And then I have to divide the standard deviation, which was,
16.
and when sometimes this comes out with some long decimals. So if this comes out 8 places, I want to write every number. You know why? Because in mathematics, we never round to the last step. And there's going to be a step 3, okay? So I do want to emphasize that. Autumn, I know we talked about rounding. Don't worry, we'll let the calculator do the hard work. We'll let the calculator do the work. But if this came out like a bunch of decimal places, I'd write them all down. But this just comes out to be a what?
125.
So when I'm going to go in here, I just want to label it. Make it look pretty. That's an x value. And what's the z-score right there? Right at that line?
0.25.
Z equals 0.25 right there. At x equal to 270 for pregnancies, has a z-score of 0.25, 0.25 standard deviations above the mean. Okay. Now the fun part. This will give us our final answer. This is where we find proportion. And when this word, proportion, I'll box it off, means probability, means area under that curve, if everything added up to 1. So to do this, to get my percentage or my proportion, probability, I always use the normal CDF button. Now, can you tell me how to enter the numbers? Proportion equals normal CDF. I'll put it right here in the middle so everyone can see this. Normal CDF. Boop, boop. here it comes. Do this is my third step every time. All right. Isn't this mean of z, which is what? What's the standard deviation of z? Cool. This is my lower z of the shaded. What's the lower z?
0.25.
0.25. What's the upper z?
1E99.
1E99. Or if you recall, Ryan just hits 9 a few times. I think if you hit 9 once, you're fine. Because, right, Ryan, 9 standard deviations. My goodness, you're way over here already. You're good with probably 1/9, but this is really for emphasis, so we can encounter any problem with this. And let me know what you all get. This is what we're doing. We're going to do this over and over. Next class, same thing. We're going to take a brief break one of these classes and do some binomial distributions, maybe the next class.
40%. 40.1.
0.4?
Yeah.
40% of that shaded, 40% is our answer. So, hey Autumn, we've talked about rounding, I know. Here's the rule. Never round this number, ever. If this came out 8, I'll keep the calculator up there and let it do it. Then when I get here, I'll type all this out. I can round this to an integer, I can round this to, 1 decimal place, but it came out to be about 0.4. Cool. Awesome.
So the 0 and 1 stay the same even though we have an actual mean and standard deviation?
Yes, and I love it. So this is where I want to go, and I should label this. Holland has a really good question. Because Holland, you're going to start working these problems in a quicker manner. Because who likes shortcuts? So do I. You're like, if I can do something short, if I can get there this way, I'll do it. This is a 3-step process. You can eliminate step 2 if you want eventually. These were all z-scores. This was my lower z. This was my upper z. This was the mean of what? Z. And this was the standard deviation of